All right, y'all, we're going to video 2. We were just up here. Now we're moving to this. Now, here is something called function notation. Function notation. There's all those words. Again, I'm not too worried about y'all's vocab right now. I'm going to be, and I am going to dump the notes later. But for now, I just want the mechanics and the basics. Function notation. What does this mean? Well, I told you that functions are a special equation, basically. And if we are going to use a special equation, we, of course, as humans, created new symbols for it. So, did we do this purposely just to torture you? No, but is that one of the side effects we love as math teachers? A little bit. So, we're going to make this as painless as possible. I'm going to go ahead and I'm going to start by looking at number 17, and I'm going to rewrite this in a understanding you already have. I'm going to say, hey, I want you to look at this equation, y equals 4x minus 2, y equals 4x minus 2, and then I want you to solve where x equals 3. Most of you have this down. Most of you are pretty comfortable with this by now, and if not, you're going to get comfortable because you got no choice. So, you see where number 17 starts with evaluate, that means solve, for f of 3. How am I going to read that to you? F of 3. Girl, what does that even mean? Well, check it out. This says f of x equals 4x minus 2. F of x, in like layman's terms, basically is the same thing as y on this level of math. It changes later on in the harder maths, but for now you can look at f of x and see it as the same thing as y. It's just y with a special set of commands. That's basically all it is. So this says y equals 4x minus 2, solve where x equals 3. How in the heck does this garbage here, whoop, she cannot draw. How in the heck does this garbage here, how does it mean all this right here? How does it mean the same thing? Well, it just does. This says evaluate f of 3. Instead of plugging in x, we want you to plug in 3. So this right here, I've already given you instructions. You already know how to do this. Solve where x is equal to 3. So in normal math, it would look like this. Y equals 4 times 3 minus 2. What's 4 times 3 is 12. Minus 2 is 10. So you'd end up with 10 as your full answer. So that would be it. So you'd plug in 3, and you would get 10 for your answer. And then you'd have yourself a point. That's what we've been doing, the XY crap. You plug in 3, and now you have 10 for your answer. That is all that's going on. I'm going to erase all this. I'm going to erase all this. You can rewind the video if you need to go look at it. And now what I'm going to show you is how we do this with function notation. Evaluate for f of 3. Cool. F of 3. What that means is this says f of x. So everywhere we see an x, we're going to replace with 3. That's what it means. So solving where x is equal to 3. Oh my God, did we just do this? Isn't this the same thing? Yep, it's the same thing. Why do humans do this? Rename stuff? I don't know. Welcome to humanity. 4 times 3 equals 12 minus 2. 12 minus 2 is 10. So you end up with f of 3 equals 10. And the other way to write that is when x is equal to 3, y equals 10. Or you can write it as a point. Why do we have them in different ways? Why do we write them in different ways? We just do. Math has different needs, sciences have different needs, and language is just a streamlined way of representing the material the best way we can. So it's an evolution and it's been going on for a long time. So now, check out 18. I'm going to switch colors. I'm going to switch to red. 18 is evaluate for f of negative 3. So remember, f of x is basically the same thing as y. Y equals 4x minus 2, but we're going to plug in a negative 3. We're going to plug in a negative 3. So this isn't that bad. Don't freak out on this. I imagine most of y'all are going to have mistakes with like your arithmetic and your multiplication more than you're going to have with the algebra. This is not hard. All of you can do this. 4 times negative 3 is negative 12 minus 2. And then negative 12 minus 2 is negative 14. So when I was all said and done, I plugged in this f of negative 3, and I got negative 14. So that point would be negative 3, comma, negative 14. And to get you used to things, the domain in this case would be negative 3, because that's x values. And the range in this particular case, in this one case, would be negative 14. Obviously, domain and range gets more complicated. Welcome to math. All right, let's go to 19. Evaluate for g of 2. Same thing. You're going to plug in g of 2. You're going to plug it in. Everywhere you see an x, you're going to now plug in a 2. Everywhere you see an x, remember when we have this exponent, you're going to replace it with parentheses first. So I'm going to plug in my 2. It's right here. And then that exponent 2 goes here. And then I'm going to do plus 3 because I'm getting it from here. Now another x. I'm going to replace it with what? It wants me to plug in a 2 where that x is. So I'm going to plug that in, plus 2. Now I just do basic math on it. 2 squared is 4, plus 3 times 2 is 6, plus 2. So you get, oh, look at that. Terrible handwriting. 4 plus 6 plus 2 gives you 12. So your answer in this case, when you plug in g of 2, is 12. And if you were to write that in point form, you'd have 2 comma 12. You'd have yourself a lovely little point. That's all that's happening. So I could work with these problems with you over and over, but you are going to finish these in class. You're going to work together as a group and try to get this down. And then I have another assignment for you that you're going to be working on that's kind of tedious, but y'all need to get this down. This is the day we have to basically get the basics down. So with that said, good luck, and I'll see you in class.